here. Okay, it's for example, it will be a server here. Is this now the font visible for people? Okay, now let me see 500. Okay, now there will be a server here. Okay, a server will store all the files F1 to F2 like this. Okay, F3 like this. Okay, we still need some mechanism for seeing how I can use it as a board. Okay, now the server will store all these files F1, F2, F3. Okay, this is a server. Now what we will have is a client which will start connecting over the network. So we have a client here. Okay, the client will now try to, okay, the client will, let us say the client 1 wants to get the file F1. Okay, now what it does is it issues a read of F1. Okay, right now the distributed program goes to the server. It knows where the file F1 is, so goes to the server and then use what is called an remote procedure call for read of this file F1. Okay, now the few KB of few KB of data will be transferred. Okay, transferred from server to client. Okay, this is what will happen. Okay, now every time a new client wants now one more file, same file is opened by another client, then what you will get here is now that server. Okay, now another client can also open this file F1. Okay, another client 2 on the network, if it wants to open this file F1, okay, then it again issues a read F1. The read F1 will be trapped now, and then a remote procedure call. This is implemented as a remote procedure call. Okay, the RPC called remote procedure call. The remote procedure call read will again get performed, and F1 will get read by it. Okay, this is what we actually call as a network file system. It's also called NFS. Okay, network file system. Okay, your systems can be available. Your files which are created under NFS will be available for any client on the network. So this is a popular way people share their files. For example, all our students' files are on the network file system in our labs. So when they log in, their entire files actually can be used from any client system. Okay, this is what we call as a network file system. Okay. Now, as opposed to this, now what you get, network file system is meant for file sharing. Okay, this is meant for file sharing. Okay, this is meant for file sharing. Okay, in a local area network, in a area network. Okay. Now, as opposed to this, what you get in the case of a Hadoop file system is Hadoop file system is similar, but then Hadoop file system is meant for okay, storing big data. Okay, if your file is very big, storing big data. Okay, now the idea is one file here is very big. Okay, a single file is very large. Okay, several terabytes, let us say, several terabytes. Okay, now obviously you won't be able to store this file on a single machine. Now what do you do actually? Now split this file into, okay, split this, this is what we're going to also show you when we actually execute the programs. We're also going to show you how we will work with the file system. Split the large file into small blocks. Okay, normally each block size for Hadoop is 64 MB, multiples of 64 MB. That means now a large file gets into several 64 MB blocks, several 64 MB blocks. Okay, this is what we will get now, and these blocks will be stored on these blocks of data. Blocks of data are stored, okay, are stored in several machines, several nodes of the network. Okay. What are we trying to do here? Okay, and these are actually called the data nodes. These are called basically the data nodes. Store the data blocks of the file. So in Hadoop file system, what we have is data nodes. They store the data blocks of the file. Okay, when you want to open a file, you need the information where no data blocks are. That's basically called the name node. Hadoop file system has called a name node. This is also called the metadata where the information on where the data blocks are stored. Okay, data blocks of file are stored. Now let us understand what this means. Okay, let us take a large file F. Okay, this is basically, let us say this is the a large file, a very large file. So this is basically, let us say, an encyclopedia. Okay, let us say this is actually let us say about 500 or maybe 1 terabyte. Okay, 1 is needed. So what will I do now? Split this, and I'll simplicity sake, I'll call this encyclopedia ency file. Okay, this file will be now split into several blocks. Okay, 64 MB blocks, n into n blocks of size 64 MB. Okay, now each of these block can be stored on a different server. So what we can say, the first block of 64 MB now is stored by a machine. Okay, 10.6.9.21. let us say this is the node on which this is. Okay, this is basically the data node. Okay, right, let us say the second block is stored, second block like this. Now we will have the second block of 64 MB is stored on 10.6.9.33, something like that. This again becomes the data node. Okay, so you have several data nodes where the data is stored. Okay, is that clear now? So you'll have all of this stored. Now finally, what will you do? You will have a name node. Okay, the name node will be, let us say, 10.6.9.2. this is my name node. This is the name node. What will the name node will have now? The name node will have this ency file. Okay, the data about this metadata is block 1. Okay, stored on 10.6.9.21. Okay, block 2. Okay, like this, it will give you now the metadata information. So now if you want to access this these blocks, where they are actually now resident is available, this information is available in this name node. Okay, so the Hadoop file system has this architecture. The architecture is, you have data nodes and you have a name node. Name node has the information about where the data is stored. For example, given this file, you can now figure out, going name node, you can ask for this file, then it will have all the information about where all the blocks of this file are actually stored on the data nodes. Okay, now this is a very simplistic understanding I am for you to figure out how the Hadoop file system works. So what is the basic meaning of an Hadoop file system? The basic way the Hadoop system works is by splitting a large file into small files and small data files, and storing each of these data blocks into the data nodes, and keeping the information about these data blocks in the name node. Okay, right? This is the fundamental understanding of what we call as a Hadoop file system. Okay, that there are name nodes and there are data nodes. Okay, now there are several ways this there are also other deeper concepts. For example, the blocks are actually replicated, which means that several copies of each of these block can be stored. For example, you can specify the replication factor, okay, the replication factor of this file, okay, which means that every block 3 copies of the data will be stored. Now here you can actually, for example, if you have 1000 nodes, then you can say one copy can be in the same rack, or one copy can be in a rack in the another rack in the same cluster, or a third copy can be somewhere else outside this data center if this possible. So you can specify where all the copies can be stored. Okay, this is basically called the replication. Okay, Hadoop file system mainly uses this replication factor for making the file system available. Okay, we'll go further into how this is actually built. For example, there's also protocols by which the name node and the data node keeps communicating with each other all the time. Okay, so the name node knows which are the data nodes that are currently available, which are the data nodes that are actually failed, then takes care of actually replicating those blocks that are there in that data node into other nodes as well. Okay, now how does this Hadoop file system works, HDFS works? Okay, this is only again a very simplistic understanding of how the Hadoop file system works. Okay, the client wants to read a file. Okay, wants to read a file. Now what does it do? It actually now goes to the consults the name node. Okay, consults the name node for the file. In this case, if it is encyclopedia, it consults the name node. What does the name node give you? Now name node returns the data nodes of the data nodes where the data nodes are present. Okay, data nodes to the client. Okay, after this the client directly interacts with the data node to read the file. Okay, this is how it works now. Okay, now what is the protocol? Now first, if a client wants to read a file, in this particular case encyclopedia it wants to read, it goes and then gets the blocks from the what are the blocks, what are the data nodes where the blocks are stored. The 64 MB blocks are stored. It goes and consults the name node and gets that information. And the client starts directly interacting with the data nodes, okay, in reading the whatever the contents of that file. Okay, now remember, this is a very high level simple description of the Hadoop file system. In fact, we'll show you as we go further how to actually create a Hadoop file system and how you can work with the Hadoop file system. Okay, but then this understanding at this point of time is sufficient. Okay, so given a large file, you will split the large file and store it on multiple nodes. Okay, now let us say we have taken this encyclopedia, which is about 1 terabyte. We have split it into several blocks of 64 MB. Now what is it that we want to now? Possibly we want to do count keywords, okay, or count how many times, okay, okay, the word Jankiram occurred. Okay, Jankiram occurred in in ENCY file. Okay, ENCY file. Okay, now the file is quite big, so it has been split into multiple parts. Now this is what we mean by now using for processing this big data is where the Hadoop Mapreduce framework will come. Hadoop will divide the file. Now, by writing the Mapreduce code, now you will make it work with this distributed file system and get the result for it. What is the way normally you would have done it? You would have written for 1 terabyte one small C program or Java program which goes and reads that file and figures out how many times the word has actually occurred. Okay, that would have been a very simple thing, but then now we know that one node will not be able to handle that 1 terabyte of file. Okay, right? Okay, now how am I going to do the MapReduce programming on this? So what I will now do is write a map. Okay, for actually doing a distributed program on this, I will write a map function. Okay, what the map function does is the map function takes a key and a value pair. Okay, this is what it will take, and it will throw another key one and a value pair. Okay, this is what it will do. Okay, now in this particular case what I'll do is read, okay, each line of the, okay, this is a distributed file, so I'll say read each line of the file, then check whether, check if the word this is present. Okay, Anikiram is present, then okay, throw, okay, then throw the result. The throw result will be now this file, this Jntuk is the key and it occurred one time. Okay, this is what will be thrown by this map function. This is my map function. Okay, it takes the line number as the key. Okay, and then it throws, for example, what is it doing? Each time it reads the line number. So line number will be, let us say the input for this is number is 001. Okay, this is the value. Okay, and what is the value? The value is Janaki Ram is a nice guy. Okay, I'm just making myself a nice guy. Okay, hope you have no objection to this. Okay, then I'll just say that now this has to throw this. It just throws that saying there is a value is 1. This will be the output of this. This is what each map function does. Okay, now what will the reduce function does? Now the reduce function takes the, now reduce function will take now this key one pair which we are throwing, things will come here, and then all that it does now is this set of values it picks up, and then it says that now value is to, it just sums up all the values that all the maps have thrown, value 1 plus 2 plus what is this, actually will sum all the things, and finally it will actually now throw a key value pair. The key value pair in this case is going to be the Jankiram, and then how many times, 10, 100, whatever number of times it has occurred, will finally throw this result for you. Okay, this is what the reduce function does. Okay, now as you can see, this whole thing of writing, now my whole distributed program is reduced to writing a function and a reduce function. Okay, now I just write and give it to the system. Now what the system does, system actually decides where all the maps are running, so give this function to the scheduler. What the scheduler does now, it creates maps. Okay, it creates the map slots on, let us say 10, 6, 9, 44. It should pick correct nice things. For example, where the data is, it picks up, that will be good. Okay, 40 to this, all these things we'll see there. So it creates map slots. Okay, it creates somebody who can create the reduce slots. That means who can run the reduce slots. So 10, 6, 9, some 55. So I create 3 maps, 1 reduce slot. Now what happens? Now this 10, 6, 4, 10, 6, 9, let me assume for the time being this is also a data node. Okay, so the data node, this is already having a 4 MB block here. Okay, on this now I'll run the map job, whatever function that I had given. This running map, what it will throw now, it will throw how many times the Janaki Ram key has occurred. So this will keep throwing all the values that it has actually found in all the. So this will be the output of the map. Okay. Now this will be maps will be sent to the 10.6.9.55 where the reducer will be running. Okay. Now the reducer will pull all the output of the maps. Okay. Maps. And now this will now wherever they are, they're all pulled. Now this all this is actually pulled now by the reducer. Reducer function now sums everything and finally says this has occurred some 100 times. This is how this program will work. Okay. Now except writing the initial map, just the simple map code and the reduce, the rest of it is all done by the system for you. For example, how many nodes it is split into, how many actually maps are required, how many reducers are required, none of this you're going to worry about. Okay, right? So this becomes all automatic for you. Once you've created the Hadoop file system, a large file is split. Come back to the we'll start drilling down and we'll start going deeper into the this whole thing. Okay. Okay. Okay, I'm only using the desktop now. I think I'm not using the board. Hope that's all right. Okay, I'm actually no, I have stopped using that. Now I stopped the desktop sharing. I want to talk to you a little bit now and then go deeper in the next class to actually show you how this in reality this works. Okay, now come back to my original. No, I have 1 lakh pages. Okay, I distribute it to 10 people, 100 people, 200 people, how many ever people are available for. The way I've written my program is what the map function do, what the reducer function do. Now what will I do? I'll give the map function to all the guys. If there are 10 guys, I'll give 10 maps. If there are 200 guys, I'll give 200 maps. That's automatically done by the system. Similarly, the reduce is automatically given. My programming job is only to write the map function and the reduce function. How many maps, how many reducers, how they should work with each other, how the output of map is actually taken and given to the reducer is all done by the system automatically for me, and hence that's okay. Yeah, that's automatically done by the system. Okay, so you don't do anything. You just actually have to actually create the file system. Then you use the Mapreduce framework for actually reduce jobs. And this is what we mean by the big data processing. Okay, if you have large data, obviously if you're trying to write a Java program for doing the Mapreduce programming, it is going to be extremely, you sit down now, do all the socket programming and take the code to actually execute it, bring the result back. It's going to be extremely complicated. But whereas in this particular case, it becomes simply, writing the map and the reduce function and then running this in the Hadoop framework. Okay. This is a very high level description of how we will do the big data processing. Okay, we start going deeper on this. We'll show you now what are the intricacies of actually writing Mapreduce programs and what are the intricacies of actually executing these Mapreduce programs on big data. We will show you by actually using the cluster. For 2 colleges, we already set up the clusters. For the other colleges, I have now advisor in the lab who is working for me, who can help the other colleges also set up the Hadoop cluster, the Bosmol Hadoop cluster. As we are doing it, you can also do the exercises, and also you can do, you can do the some of the assignments. Some of them can lead to projects which you can pick up and then give it to your students and work on it. So I will introduce this project advisor class so that he can help the colleges, in setting up the cluster. Whatever help they require in setting up the cluster, he will sort of help, and also help in running the assignments by the colleges. Okay. So what is the difference between key and the key one in the map? Okay. The difference between the key and the key one is the look at this. Actually, for key one is basically the first key is what? First key is basically the line number. Okay, the map is taking only the line number as a key, and then the value is basically the string. Janikiram is a nice guy. It is outputting the key one, which is Janikiram 1 now. Janikiram and the value 1. Okay, Janikiram is the key 1. Okay, the word which it is finding out is the key, which is thrown to the reduce function. Now, why reduce requires this key 1? It groups based on this key 1 all the values. Okay, this is useful to understand. For example, if you have multiple keywords, not just one keyword. For example, let us say I'm not just interested in just counting one word, but I'm interested in counting, okay, all the keywords, which means that now in that particular case, Janikiram 1 becomes one keyword. The key is in this case is Janikiram. The second keyword becomes nice. Okay, nice, and then it becomes also 1. The value is 1. Okay, then the guy becomes, okay, third keyword. Okay, third keyword is actually guy and also 1. This is the key one. Okay, and this will throw three key value pairs: Janikiram 1, nice 1, and guy 1. Okay, so that is the one value. Now, for grouping all the similar ones, the reducer will use the key one. For example, based on Janikiram, if there are multiple maps throwing this Janikiram, it will group all those values and then give the final one. If the nice has occurred in multiple times, it will group all of that and give you the final value. Similarly, the guy. Okay, is that clear? I guess I have not shared I stopped sharing it, I think. See this. This is what I'm actually saying. I think I've stopped sharing, I forgot. So this is where we are saying, okay, Janikiram, the first key is 001, and then the Janikiram. Are you able to see now? Janikiram is a nice guy. This is the key value pair that the map took. What the map has thrown now? 3 keys. 3 key value pairs. Janikiram, nice 1, and guy 1. Okay. Now the reducer actually picks up all the keys based on their values. If there are multiple thrown, which is Janikiram at multiple maps have thrown, they all will be combined together. Similarly, nice will be combined, and then the guy will be combined. Okay, is that clear now? So what is the difference between key and key one in the map function? Is that clear now? Whoever asked, before I go to the next question, is that question, answer for that question clear? What is the difference between key and key one in the map function? I'm not getting the response. Okay, let me go to the next question. Can client directly interact? Yeah, okay. Can client directly interact with data node? That means client will not interact. Client will interact only with the name node to find out which data node has the blocks for that file. After that, the client will directly interact with the data node. Okay, right? Now we'll see more deeper details of it. As far as reading the data is concerned, client will directly interact with the data node. It will not go through the name node. It will first consult the name node to get which data node has the data, and then we'll get that data. How to load data into Hadoop? Do we need to split into blocks and load by block? Okay. No, actually what you will do is there are functions. For example, if you actually now first we'll see how to actually create a Hadoop file. Can client make see, basically there are multiple questions coming in here, so I'll answer one by one. Okay, how to load data into Hadoop? So basically you will give a large file to start with, to the Hadoop file system. When you want to copy it, then it actually splits it, and then starts basically there are multiple ways you can generate those files, or you can actually load those files. If one big file is there, the idea of distribution is you want to start processing in a distributed fashion. That's the reason why, given a file which fits, for example, disk space will already be available on your disk. So when you copy this into the HDFS splits this and decides the data nodes on which the HDFS will be running. So basically, before of the Hadoop file system, you have to also specify what are the name nodes and what are the data nodes, where the name node will be running and where the data node will be running. So when you actually copy this file into the, we'll come back to heartbeat algorithm. Okay, there are multiple questions. Let us go one by one. So when you actually give the desktop is not visible. I'm actually not using the desktop at this stage, but then I'll make it visible for you. Just wait for a minute. Okay. Okay, this I'm actually not using the desktop for answering this question. For example, you have 1 terabyte file. If you copy this into the HDFS, okay, then it will actually decide how many data nodes it will be going to use, and then choose and then put these blocks into those data nodes. These are all will be decided by the HDFS file system. You don't have control on it. Okay, you don't have control on it. Okay, please understand that. Okay, now what is the next question? Can client mission in the data nodes? This is like the read and write files. So if you actually change something, then you're going to write onto those files, right, onto those blocks. But you don't actually, everything is transparent to the client. The client just reads a file. A corresponding block is automatically brought to the client. If client is modifying, that data block will be written back onto the file. Okay. Then the next question, replication factor for the name node. Actually, there is a primary name node and a secondary name node, which is more for the sake of fault tolerance. There is no replication factor there. Okay, replication factor node makes sense because the data blocks are replicated. Okay, we'll see more details of the HDFS system as we go further down. Okay, sir, what is heartbeat? No, see, this is a question which I think an advanced question than what let us go one by one. I guess yeah, there are more questions today, so I'll spend a little time to answer these questions. So the idea of the heartbeat is the name node has to continuously find out information about the data nodes. So what the data nodes do is the data nodes will have a heartbeat protocol with the name node, giving all the information about the node availability, its health into the name node. Name node actually uses this heartbeat algorithm to find out if some nodes some data nodes are no longer available. Then it actually takes the blocks that are there on that data node, replicates them somewhere else, and then makes that the data node is no longer available. So heartbeat is used for variety of purposes, including the health of the data node. We will see the heartbeat protocol as we go further. Okay. There is one more question at the end. Is any free cloud service for testing Mapreduce available? What do you mean by this? Okay, I think no. As far as I know, the Elastic Mapreduce of Amazon is not free. As far as I know, the Microsoft Azure cloud is not free. Okay, I don't know if there are somebody who is making a free cloud service available for you for testing the Mapreduce programs. I'm not aware of. Okay, hope that answers the question. Okay, any other questions at this stage? Can you please list few MapReduce tasks for us to experiment on a single node cluster? Okay, this is the first class on MapReduce, so we've still not finished the explanation. So what we will do is we will try to actually show you how to run the MapReduce jobs. Okay, we'll also show you how to work with the HDFS system. Then we are going to give you some no, programs that you can run yourself on the MapReduce no, single node cluster. If you are already ahead and you actually have you ran the word count example on a single node cluster? Have you done that already? Somebody is asking this question: how cluster is related to MapReduce, because the MapReduce is running on a cluster, right? You are creating the HDFS file which is distributed on several nodes of the somebody is saying that word count done, sir. Okay, Jane, word count. Okay, we have already done word count. Try to do the following. Okay, this is an advanced this thing for you. Find out if a pair of words, how often they're in the, not just a single word. Okay, you look at, no sir, we have some doubts on how to install Hadoop on a single cluster. Okay, so basically uh, we're going to show you how exactly what are the doubts you're having in installation of the Hadoop on a single cluster. Can you do the following? Okay, in the next class I'm going to, on Friday possibly, I'll give it to one of my students, okay, who will actually tell you how to download the software that we have here, okay, and set up a Hadoop cluster. Okay, on Friday, let me see if I can actually, I think the both Kakinada and the Vijayanagaram had that, somebody helped them to download the Hadoop, and then I'm not going to take the class both on Friday and Monday. Okay, I'm not available, but I can see if somebody from my lab can help you. Actually, if you have a lot of doubts about how to install the Hadoop, I can actually ask one of the students, my students. They actually helped. I think the CDAC people also helped in actually providing the access to actually how the cluster can be set up in the in two colleges. They can provide the help in setting up this for the other colleges as well, right? Okay, right. So I think then I'll see if Friday if there's somebody available to take class. I'm not taking the class on Friday. I'm also not taking the class on Monday. Okay, yeah. Pair of words. Yeah, somebody is saying pair of words. So now see basically take any if I have a pair of words and I want to find out within, if they occur within a distance from each other, okay, I can specify the distance, the maximum distance within which they can occur. Then I would like to figure out all those pair of words. Okay, oh gosh, there are too many questions this time. Yeah, take any pair of words and then see how this pair of words, the distance between those pair of words, and see how you would like to use that. For example, I want all the co-occurring words. Okay, this is not, this is slightly difficult assignment. Okay, you want to find out all co-occurring words in a large file. Okay, the co-occurring word, for example, Janaki Ram and a nice guy, or something like that. Okay, so these are co-occurring good, and you can also specify by within 3 words distance. If these 2 words have a maximum distance of 3 and they're co-occurring, then I want to find out all co-occurring words in my large document. Okay, if you have already done the word count example, please try to find all co-occurring words, write a MapReduce program for all co-occurring words in your document. Okay, word pairs. Okay, co-occurring, you know, co-occurring document, co-occurring words in your document. Is that clear? Okay, that's an assignment. If you have already done word count, okay, try to write a MapReduce program for co-occurring words. Okay, now okay, the 48 has some other question. Facing the problem of changing the port number every time for each execution. What does that mean? What is the question there? Facing the problem of changing time for each execution. For what? You don't need to change the port number. Why are you changing the port number? Oh, in virtual server. Okay. Yeah, that I think you don't have a easy answer for it, because you're running it in a virtual server, right? So you have to actually, even then actually, there should be some way get that. Where is your virtual server running? Have you put it in the cloud? The IP address changes, the port number doesn't change even then, because the program only opens the port number in DigitalOcean. Yeah, if you're using DigitalOcean and then you put your virtual server there, then I think you have to change each time you actually get a new IP address, you have to change the IP address, not port number. Actually, you will change the IP address, because each time you get a new server, the IP address will be different. Only way you can solve this problem is you can buy a IP address, and you can say that your virtual server should always have that IP number. You can tell that, but then that will be more costlier compared to just asking for a virtual server. Okay. Yeah. Okay. Then I think we will sign off here. We'll come back next time.